All right, here's the problem we're going to be doing. I've got f of x equals blah, 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 2x cubed minus 3x squared minus 2x plus 1, and g of x equals x cubed plus 3x squared plus minus 13x plus 7. Here's what else I have. I have the graph as best as I could. Now, I mean, you can make this graph on a graphing calculator. You can graph this, I don't know, just try to graph it the best you can. It doesn't even need to be a perfect graph. This is an ugly, ugly graph that I just drew up here because I didn't necessarily make everything completely straight or everything. The first thing we're going to do is we're going to identify what these two polynomials are. This is a cubic function because of the x cubed. Agreed? Tell me what you guys think. This as well is a cubic function because of the x cubed, right? Now, I'll be honest with you, this thing right here looks like a polynomial, it looks like a parabola. It doesn't look like a cubic function. You see what I mean? Whereas this one right here, the dotted line one, that one definitely looks like a cubic function. But who's to say that maybe we didn't zoom in on this parabola-looking one so much so that it looks like a parabola, that we're only seeing the piece of it that looks like a parabola, because the cubic function is made up of, I guess, two parabolic-looking shapes. You know, you've got the upside-down parabola and you've got the right-side-up parabola. Who's to say that for this one right here, that solid line one, we aren't zoomed in right there? You guys see what I mean? So even though this doesn't look like a parabola, maybe who knows? Maybe this thing goes up and then comes back down, and it just is outside of the scope of where our graph is looking right now. Okay? Now, I guess I got to identify. I didn't label which one is which. I'm guessing that this dotted line one is f of x, and this solid line one is g of x. And I'll tell you my reasoning behind that. Okay? What is the y-intercept of g of x? 7. Perfect. Great job, Elijah. It's 7 because you look at the g of x and you plug in x equals 0, boom, 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 those are all 0, plus 7, that's what your y-intercept is. So I'm guessing that this thing goes up and crosses over here way over at y equals 7, which is off my graph. That's why I'm thinking that this solid line one is g of x. And then what is my y-intercept of f of x? Somebody hits up Elijah, answer please. Elijah just kind of gave you the heads up on how to do it. So what is the f of x for, or the y-intercept of f of x? It's equal to 1, exactly. And if you look at the dotted line, ba, 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 boom, right there. At at x equals 0, y is equal to 1. So that's how I'm guessing that this dotted line one is my f of x. The solid line one is my g of x. Did I confuse anybody here yet? I haven't even really started per se. I'm just trying to kind of get, we're getting into it. All right, now, what I want to find is when is f of x bigger than g of x? And I can tell you where my guess is. All right, f of x is smaller. The value, all the y values of f of x is smaller than all the y values of g of x in this area over here, in this region right here. Got it? And all of the y values of g of x of f of x is also smaller than g of x in this region over here. You can look at that by looking at the graph. Which one's on top? So my f of x is actually bigger. It looks to me like my f of x is bigger between this, let's see, let's use like a green marker, in this region right around here. You guys see what I mean? I know it's hard to see that green marker, but I didn't actually want you to see it very solidly. I just want you to see in this shaded area right here. That's where my f of x, the dotted line one, is bigger than the g of x one. Does that make sense to you? Now I admit to you, I'm just looking at the graph. I can't really tell for sure which is bigger and whatnot. But I can, what I'm doing is I'm kind of looking at the graph. Now, I would say, if I were to give you an answer, I would say that it's between what looks to me like x equals, f of x is bigger than g of x when x is bigger than 1 and smaller than 2. That's my guess. That's my best guess that I have. Just from looking at this graph, I can say it's about there and it's about there. Now, I can't necessarily tell you, guarantee that's completely true, unless, of course, I check something. What I would do if I were you is I would plug in x equals 1 into this equation up here and this equation down here. If I plug in x equals 1 into the equation above and x equals 1 into the equation below, what will I get? Will I get the same answer? Will one of them be bigger than the other? What do you think? I'm going to wait. What are your thoughts? IDK. You know what, Justin? I like your bravery to just straight up just say, I don't know. That's fine. I'm perfectly fine with that. What else do you guys think? And I commend Justin for saying, I don't know. At least I know that you're alive. If I plug in f, all right, here's what my question is. F of 1, g of 1, are they going to be equal? Is one going to be bigger than the other? Is it supposed to, am I supposed to erase this equal sign and make it like this, or erase that sign and make it like that? What are your thoughts? I'll wait. And if another person says, I don't know, I'll just tell you the answer. Come on, say something. You wrote G, Kaylin. I'm not sure what you mean by that. You're saying that G is going to be bigger? Okay, I see what you mean. Okay, Kaylin, you're wrong. Justin, you said I don't know. I'm going to try to just tell you the answer. It's equal to. Because I told you that it looks to me like anytime x is smaller than 1, then the f of x is going to be smaller than g of x, right? And it looks to me like anytime x is bigger than 1, then f of x is going to be bigger than g of x. They switch paths. Does that make sense to you? So 1 is kind of my crucial point. And if I'm arguing that that this all happens at x equals 1, then at x equals 1, if they cross paths, then right exactly at x equals 1, they should be equal to each other. Does that make sense to you? If they both happen to cross paths, if one is bigger than the other, and then right after the value x equals 1, the other is bigger than the other, I mean, then they switch sides and the other one's bigger now, then right at that part where they switch sides, they should be equal to each other. That's what I'm saying. Does that make sense to you? Because what I'm trying to do is this was just a guess. This was just looking at the picture and saying, it looks like to be about there. But what the point I'm trying to make is that you can't do that. You can't just say, it looks to me like that's really close. What you have to say is, you have to tell me for sure that's true or not. So what I'm saying is why don't we check to see if at that exact point they are equal to each other? Because if at that exact point they are equal to each other, then I can tell you that before that they do switch. Does that make sense? So, let's plug in, all we got to do is plug in x equals 1. So f of 1, what is f of 1? It's pretty straightforward, it's pretty simple. You just plug in 1 into here. I'm going to do it quickly. 2 times 1, that'll just be 2, minus 3 minus 2 plus 1. I like plugging in 1 because when you plug 1 into x cubed, you just get 1, x squared is 1, this is 1. You just multiply it all out. That's pretty simple. Let's see, 2 minus 3, that's negative 1, minus 2, that's negative 3, plus 1, that's negative 2. So this is equal to negative 2. So the y value of f equals 1 is negative 2. Does that make sense? Okay, good. G of 1, that's pretty straightforward as well. 1 cubed is just 1, plus 3 times 1, minus 13, plus 7. All right, let's see. 3 minus 13, that's negative 10, plus 7, that's negative 3, plus 1, that's negative 2. That was just addition and subtraction. That was nothing fancy schmancy anything. All I did was I just said 1 plus 3 minus 13 plus 7. You guys happy with that? Now, see, f of 1 is negative 2, g of 1 is negative 2, so I can tell you that they have the same y value in between here and here. So I can tell you that they definitely do cross each other, or at least they touch points. Does that make sense to you? At the value of 1. Alright, now all we got to do at this point, is it alright if I erase this part? If this made sense to you, I'm going to erase that for you. Because I need more room. Okay, erasing now. Now that I've checked this one, I simply have to check this one right here. 2. I want to see if they also cross at x equals 2. Because that's what the graph looks like to me, but I can't really tell that until I check it algebraically. So that's what I did, is that when I plugged in 1 for x over here and 1 for x over here, that's checking that value algebraically. I'm going to plug in the 2 over here. So what is f of 2? That is, oh, that's a little bit more complicated, not that bad. It's 2 times 8 minus 3 times 4 minus 4 plus 1. Do you guys see how I got 8, 4, 4, and 1? Yes, no, I don't know. Make sure you say I don't know if you guys are confused. Stop me if you guys don't know what's going on. All right, good. Yeah, all right, okay. So let's see, that's 16 minus 12 minus 4 plus 1. Okay. 16 minus 12 minus 4, that's 0 plus 1. That's simply equal to 1. So f of 2 is equal to 1. What is g of 2? Okay, that would be 8 plus 3 times 4 minus, okay, this would be 26 plus 7. All right, so that's 8 plus 12. 8 plus 12, that's 20, right? Then you add another 7, so that's 27 minus 26. That's also equal to 1. Did I lose anyone there, or did that make sense to you? All right, good. So f of 2 is equal to 1. G of 2 is also equal to 1. It's telling me that they also cross at that point. Now, I think that, to be honest with you, that's enough. You did enough work to say that f of x is bigger than g of x when x equals, or if x is between 1 and 2. You don't put the bigger than and equal to sign, because when it's equal to, that's when they're, f of x will be equal to g of x. So I only want to strictly when x is bigger than 1 and when x is smaller than 2, because that's the value when f of x is going to be bigger than g of x. I think you did enough because you looked at the graph, you verified that those are your crossing points and whatnot. If you wanted to, I guess you could take this one step further. And what you could do is you could check to see if some point way out here is, will make this, or you'll see what the x value is, or the y value is here and the y value is there, at some point in this region, and to see if that's actually true. Or you'll see if it's true within this region. So you can choose an x value like 3/2. And you plug in 3/2 in for x over here. That makes it a little bit more complicated. But I mean, you can just use your calculator, plug in 1.5, 1.5, 1.5, all in here, and see if indeed f of x is bigger than g of x. Because maybe you can't trust the graph at all. Maybe Mr. Dalde just threw up a graph out there just to completely mislead you. And he totally would do that. You guys get it? Does that make sense?